Hello and welcome to day 6 of surface area of regular prisms. And so in this section we are going to find the surface area of this regular prism, and so we need to remember our surface area formula for any prism, and the surface area formula is 2 times the area of the base plus the perimeter of the base times the height, the distance between the two bases. This is the same formula that we use for rectangular base prisms, for triangular base prisms, for any base prism, except for the area of the base formula is going to be found by, in this case, the apothem times the perimeter of the base divided by 2. And so this is where it gets a little tricky on this one. We can kind of work our way around and find like the areas of all the lateral faces of all the rectangles, and then find the area of the 2 hexagons. But we've got to find the area of the 2 hexagons first. Well, we'll do that first. And so I'm looking at this. I'm going to draw an apothem. And then I've got this angle here, this triangle. So this is the triangle I'm dealing with. It comes from the 2 radii of the shape, and so basically we need to figure out what is the measure of that central angle in there. And so the central angle is going to be 360 degrees, because that's once around the circle, divided by 6 sides, which means that central angle is 60 degrees. That whole angle inside here is 60 degrees, which means this one is 30 degrees. Well, if that's 30 degrees, then that means that this angle over here is 60. It's twice as big. And so we know a few things about this. We know this side length over here is 12, and it was cut in half by the apothem, so that makes that piece 6. We know that if we double that, we will get the radius, which is 12, and then if we take that times root 3, we would end up with the height, the apothem in this case, which is going to be 6 root 3. So we could have done trig if we wanted to find that length there for the apothem, but since it's 30 degrees, we can go ahead and use our special right triangles to find the apothem. So now the area of my base is going to be 6 root 3 times the perimeter of the base. Well, the perimeter, all the sides are 12 all the way around, and there are 6 of them, so it's going to be 12 times 6, and we'll divide that by 2, and that will just be the area of the base. Now, I could not divide by 2 here, because I'm going to end up multiplying by 2 in the original problem, and that would give me the area of both bases. But I'll just get the area of one base, and then we'll go from there. So the area of one base, and I'm just punching this into my calculator, and I end up with 374.12 for the area of the base. Now remember, I'm going to multiply that by 2, so that's my first thing. So for my surface area formula, I'm going to take the area of the base, which would be that number right there, and multiply it by 2, so 374.12, plus the perimeter of the base. Well, the perimeter is 12 times 6. So the perimeter of the base is 12 times 6 sides, so there's my perimeter of my base. And then the height, the distance between the hexagons, is 8, and so I'll multiply that all by 8. So now to find this, I'm going to type this all in on my calculator and get a number. And I end up with a surface area of 1,324.25, and we're talking miles squared. And so that's the surface area. So just like our other prisms that we were dealing with, we would find the area of the base, which in this case happens to be hexagon, and then we're going to multiply that by 2 and add on the area of all the rectangles. And we could have done that, if we know the area of the base is this, we could have done, the surface area of the base is 374.12, multiply that by 2, and then add on all the rectangles, and the area of one of these rectangles is 12 by 8, and how many are there? Well, we could add it on 6 times, or we could multiply by 6, which is basically what's happening right there. So just be prepared. This is what we're going to be doing in class. We'll have time to practice this, but if you have any questions, please come to class prepared to ask them. Thank you.